Welcome back to You Revise, where we talk about everything exams. Let's take a look at question 17 from the 2016 exam. It reads, three metals A, B, and C were tested to compare their reactivities. Samples of each metal were placed separately into test tubes, each containing a nitrate solution of other metal ions. The following results were obtained. Now, so we are saying, what they are saying here is you had metal nitrates of these three metals, right? So in the metal nitrate for A would have been A nitrate, like that. B nitrate, C nitrate. Okay, and so you had these nitrates, and in each of these, let's say this was A, B, C. What you would do, you'd place the metals of each of these. So in A, I'll place B, and then I'll take A again and test it with C, and so forth and so forth. And these were the results that were obtained according to them. Now, to be able to answer this question, which the examiner states that only 50% of candidates got this question right, you needed to understand the concept of displacement reactions, which says a more reactive element is capable of displacing a less reactive element from its compounds. So, for example, if I've got potassium, this is what I teach my students. All elements here, like that is on elements on the right, are capable of displacing elements that are to the left and above them from their compounds. What do I mean by that? Let's say I take potassium and react that with barium nitrate. Right, because potassium as a solid is on the right, and barium, when it's in barium nitrate, it actually exists as barium ions. It's capable of displacing barium from barium nitrate, and I will end up with barium solid being produced plus the potassium nitrate. So potassium nitrate has taken the place of barium in this salt. I'm not bothered. Let me just balance that for, it's like I've got 2 here and I'm going to have 2 there. Right, okay. So this is what we mean, that potassium is more reactive than barium, so it's capable of displacing this. So a reactive element can displace a less reactive element from its compounds. That was the simple rule you needed to know for this one. So let's take a look at what's happening here according to the data that we've been given. We've got A interacting with B. There was no visible reaction. So this is just like, for example, saying barium trying to react that with potassium nitrate. Because potassium is barium, if we look at barium as a solid, it can only displace those are to the left and above it from their compounds. Potassium in this case is to the left and below barium, so it cannot displace that. So that's why we will say there's no visible reaction in this case. So what it means here, when B produced as a solid is not capable of displacing these A2 plus ions, it means B is less reactive than what? Than A, because it's not capable of displacing it, just like barium is not capable of displacing potassium from its compounds, and therefore barium is less reactive than potassium. Let's look at this one here. A interacting with C, which means solid A forms. So what's happening here, if we take C as a solid and interact that with A2 plus ions, we end up with A being displaced and producing C2 plus ions, which means C is more reactive than A. It's capable of displacing A from its compound. So in this case, C is more let's just put it this way, A is less reactive than C. I'm just doing it in a way that my brain works better with this. You can do it whichever way, but in terms of placing these. So we can see that if A is more reactive than B, but A is less reactive than C, which follows that C would be more reactive than B, which we can see here. If we take C and mix it with, where is C solid, and mix it with B, C is capable of displacing B, forming a solid. So in order of reactivity here, just using this logic, we can say C is the most reactive, followed by A, followed by B. But let's see what the question is asking us. In order of decreasing, which means from the most reactive to the least reactive. Most students get caught up in this. They don't, because usually sometimes they say in order of increasing. So be mindful of this word, in order of increasing, in order of decreasing. It trumps up a lot of students, because if it was in order of increasing, there might be an answer that is there. Let's check here. So the order we are looking for is C greater than A and A greater than B. So which is A? That's our correct answer. Let's look at this one there. B cannot be greater than anything, because we have seen that B is the least reactive. Now, this one is saying A greater than C. There is no way A is greater than C, so this one is completely wrong. So that leaves us with A as our correct answer. Obviously, by using the electrode potential tables, I'm also reminding you of how you can use this to write and balance single displacement reactions. It's so amazing how many students get those questions wrong, because they are not bothering to apply this rule or use this tool that they have. It's just a tool that's there for you to use. Right, so I'll repeat that again. Any element that's on this side of the half equation is capable of displacing anything that is to the left and above it from its compounds, and the table works the same coming down. But for most of your single displacement reactions, this is what you're going to see. And then when you're dealing with nonmetals, it's to the left and down. Right. I hope to see you when you come back to attempt other questions. Thank you once again for watching. I shall see you in the next video. I hope this video was very helpful, and I would love to hear any questions, any concerns, or anything that you think could have been done differently in this video.